Hi, you guys. I'm going to go through a couple of the problems from the mole reaction worksheet. So the purpose of this assignment is really just to have a lot of practice with using the delta H values as a conversion factor, using that to help us convert between units of grams and moles to units of energy. So just a reminder of just some things that we can set equal to each other so that we can use them as conversion factors. So like in this reaction that's given in the background stuff, we've got just the simple reaction for hydrogen and oxygen producing water, and that being exothermic because my delta H value is negative. For every mole number of times that reaction takes place, there's 570 kilojoules of energy that's released during that process. So when we have that delta H value, there's a couple things happening. Basically, for 1 mole of reaction, negative 570 kilojoules. 570 kilojoules are released, okay? So that's kind of like the main thing that's going on with our delta H value here. But within that reaction, we also have some things that we know because of the coefficients that are in front of all of the different parts of the reaction. So if I have this reaction, 1 mole of this reaction happening, I'm going to need 2 moles of hydrogen gas to make that happen. I'm going to need 1 mole of oxygen gas to make that happen, and it's going to produce 2 moles of water. So all 5 of those things are equal to each other. And so depending on the problem that I'm trying to solve, I can use any of those 2 things as a conversion factor. I can convert from moles of hydrogen to kilojoules. I can convert from moles of water to moles of hydrogen. That's stoichiometry, but like you get the idea. All of those things can be considered to be equal to each other, and they're all equal to this weird thing of 1 mole of reaction. If I have that reaction 1 mole number of times, then it's equal to all of that, okay? So let's go down. I'll go ahead and do number 1, and then I'll do one from the other page. So basically, it kind of just depends on what you're starting with. So in number 1, we have 222.4 grams of N2. So you just kind of have to work with, okay, what unit am I starting with and what unit do I need to get to? So I'm starting with grams. So automatically, remember the whole point of this practice is to use my delta H as a conversion factor to get from moles to kilojoules. Well, I don't have moles or kilojoules here yet. So that means I need to convert first from grams to moles. So I need the molar mass of N2. That's something you can find it on your periodic table. That's going to give me 28.02 grams per mole of nitrogen. Not done, because the question is determine how much energy, which it doesn't say specifically what unit to use here, so I can go ahead and use kilojoules. If it would ask for joules, then you would have one more conversion to do at the end. Now, my conversion factor. Okay, this was moles of N2. So if I want to cancel out moles of N2 and I want to convert that to kilojoules, let's go back to my reaction and let's take a look at what I'm dealing with. Moles of N2, there's my N2, there's my delta H value. So that means if I can set everything in this reaction equal to each other, right? 1 mole of reaction equals negative 91.8 kilojoules equals 2 NH3s, 3 H2s, 1 N2. So whatever that coefficient is in front of nitrogen, I can go ahead and put that down there. And for every 1 mole of N2, that's going to be negative 91.8 kilojoules. That's going to give me, then I multiply everything on the top, divide by the bottom. I get negative 729 kilojoules. Okay, now, we're not quite done because this says determine how much energy is given off. So there's a couple different ways that you can answer this question. You can go ahead and do negative 729 kilojoules, but since the wording of the question says how much energy is given off, we can go ahead and write 729 kilojoules as like my final answer, because that's going to tell me how many kilojoules of energy are released. Like you wouldn't say negative 729 kilojoules are released. You would say 729 kilojoules are released. Negative answers would be accepted here because, you know, you did the math correctly, you have the sign correct. But the wording of the question, just pay attention to that. If it just says, you know, what is H, then you have to make sure you include the positive or negative. But if it says how much is released, then you can like absolute value that and put that in your answer. All right, let's go ahead and let's do one that's a little bit different. Let's go ahead and do let's see, I've got grams and moles. I'm looking at the second page. So some of these questions, you're given moles instead of grams. If you're given moles instead of grams, then you can just skip that molar mass step. Let's go ahead and go down to number 9. Okay, in number 9, it is asking me what mass of SO3, so mass is in grams, and is needed to generate, that means it's going to release 1,566 kilojoules. Okay, it's important for me, again, to add that negative in front because I'm generating, I'm producing it, it's releasing that amount of energy, so that has to be negative. Otherwise, you're going to end up with a negative number of grams at the end, and you can't have negative numbers of grams, okay? So whatever number you're given in the problem, that is the number that I'm going to go ahead and start with the correct algebraic sign, which is negative 1,566 kilojoules. This one is also asking me for grams of SO3. So I need to make sure I pay attention to that. My delta H value is negative 570.2 kilojoules. Now that's per mole of reaction, but now let me go back to my reaction and find where SO3 is. SO3 has a 3 in front of it. So that means that's my number of kilojoules that are released for every 3 moles of SO3. I should have put units of moles right there. There should be moles like right there. Okay, so for every 3 moles of SO3. So now I can go ahead, the question's asking me to solve for the number of grams, right? So for every 1 mole of SO3, I do need to find the molar mass of SO3, which is 80.06 grams. Okay, that gets me from units of kilojoules to units of grams. I can go ahead and multiply by the top numbers and divide by what's on the bottom. That's going to give me an answer of 660 grams as my final answer. Now, let's say that you forgot to do this part right here, which is to take my 1,566 and make it negative. If you forgot to do that, and you know that affects this number right here, if you don't do that, then you're going to end up with a negative number of grams. The number would be correct, but the sign would be wrong. So if you got a negative number of grams, obviously you can't have that. So you need to go back and figure out if you forgot to change a sign somewhere or something like that. Okay, so this assignment, all about using delta H. Delta H is a conversion factor to get you from energies to moles, which you can convert to grams and all of that kind of stuff, using all of the coefficients in the reaction that can all be equal to each other to use as conversion factors and equal to moles of reaction, and using our delta H value there. The answers are given to you guys down here at the bottom. So as you guys are working through numbers 1 through 10, you guys can check your answers and make sure that you are doing everything correctly. This is due on Monday, and I'll be checking it off in class on Monday. All right, so you guys have a great day, have a great weekend, and I'll see you guys next week.